everyone, this is Madhvira Mulya. In the today's session, we are going to discuss to the air bladder of fishes. It is also known as a swim bladder of fishes. Now we will discuss to the introduction of air bladder in fishes. The air bladder or swim bladder is more or less a sac-like structure laying dorsal to the alimentary canal and directly beneath the vertebral column and kindly but outside xylem. The air bladder or swim bladder is a pouch-like structure. It is located dorsal to the alimentary canals and directly below to the vertebral column and kidney but outside below. It is a characteristic organ of ostrich fish. It is also known as a bony fish. All bony fish have a air bladder. It is a gas-filled pneumatic sac called air bladder or swim bladder. Air bladder does not occur in elasmo branch. Air bladder is a pneumatic sac-like structure. This sac is fulfilled to the air, so it is called as a air bladder. And air bladder does not occur into the elasmo branch fish, means cartilage fish. Cartilage fish not have a air bladders. It is vestigial in Latimeria, the only living crossoptery gem. In Latimeria, fish not have a very well developed air bladders. It is found in all bony fishes but except a few bottom dwellers. All bony fishes are very well developed air bladders, but some bony fishes not have a air bladder like bottom dwellers fishes. This type fish occurs into the bottom region of sea or ponds, so it is called as a bottom habitat fish like Lophius. Now we are discussing the origin of air bladders. The air bladder arises as an outgrowth from the esophageal region of the alimentary canals. Air bladder arises into the esophageal regions, but it is outgrowth of the alimentary canals. It shows great diversity in mode of development, structure, function in different fishes. It shows many diversity in the developments, structures and function. Different fishes have different types of function. It lives ventral to alimentary canal in polypterus. In polypterus, fishes have a air bladder in the ventral side. Lateral in dipnoi and dorsally or dorsoventrally in teleost. In dipnoi fish means lungfish have a air bladder to the lateral sides, and in the teleost fish means a bony fish have a air bladder to the dorsally or dorsoventrally sides. These figures indicate a various type of air bladder and lungs in fishes. Now we are discussed to the polypterus and calamatheus fish. In this type fish, the air bladders occurs into the ventral side of the esophagus. The air bladder have two lobes, but left side lobe is small than to the right side lobe, means right side lobe is large. These two lobes open into the esophagus by ventral pneumatic duct to ventral sides. Now, Protopterus and Lepidosiren fish. These fish have two lobes of air bladders, but these lobes are similar, and these lobes are open into the esophagus. It is also located to the ventral sides. They open by pneumatic duct to ventral sides. Now we are discussing the Neocreatodus. It is an African lungfish. In this fish, air bladders occurs into the dorsal side of esophagus, but the air bladders is open into the esophagus by pneumatic duct to dorsal to ventral sides. These figures indicate a various type of air bladder and lung in fishes. Now we are discussing the last figures. These figures is a Polypterus and Calamatheus fish. In Polypterus fish have two lobes of air bladders. The left side lobe is small, then to the right side lobe means right side lobe is large. The air bladder is located to the ventral side of the esophagus. These lobes open into the esophagus by ventral pneumatic duct to ventral sides. Now, Protopterus and Lepidosiren fish. The air bladders occurs into the ventral side of the esophagus. It is similar to the Polypterus fish, but difference. The air bladder have two similar lobes. These two similar lobes open into the esophagus by pneumatic duct to ventral side. Now, Neocritodes fish. It is an African lungfish. In this fish, the air bladders occurs into the dorsal side of the esophagus, and the air bladder have only one lobe. These air bladder open into the esophagus by pneumatic duct to ventral side. Now, and Lepidostresus fish. The air bladders occurs into the dorsal side of fish. Have only one lobe. The air bladder open into the esophagus by dorsal pneumatic duct to dorsal side. Now, Erythrinus fish. This fish have a air bladder to the lateral side. This lateral side air bladder open into the esophagus by pneumatic duct to lateral sides. Journal-teleost and Accipenser. In this fish, the air bladders occurs into the dorsal side of esophagus. The air bladder have only one lobes. These air bladders open into the esophagus by dorsal pneumatic duct. So, this type air bladder is known as a physostomous air bladders. Now we are discuss to the specialized teleost fish, means bony fish. In this fish have a air bladder, but it is not connected to the esophagus. It is a free. So this type air bladder is called as a physoclistous air bladder. Now explain these figures. Types of air bladders. Depending on the presence of duct pneumatics between the air bladder and the esophagus. Types of air bladders is divided on the basis of depending on the presence of duct. Without duct is called as a physoclistous air bladder, and with duct air bladder is called as a physostomous air bladder. So the air bladder in feces can be divided into two broad categories. First is physostomous, second is physoclistous. Now we are discussed to the physostomous. The air bladders have a duct. It is called as a physostomous air bladders, and physoclister air bladders. So the air bladders not have a duct. It is called as a physoclistous air bladders. Now we are discussed to the condition in ganoids and dipnoids, means lungfish. In most primitive fishes, the air bladder serves as an accessory respiratory organs or lung, which seem to have its original function. In dipnoids or lungfish, the air bladders used for the accessory respiration organs. It is a original function. In Polypterus, one of the most primitive bony fishes living today. It is a smooth-walled bilobe sac with a short left and long right lobe opening ventrally into esophagus by a single duct. This duct is called as a pneumatic duct. We has discussed in figures. In Polypterus fish have two lobes, but left lobe is small than to the right lobes. Now this is open into the single duct of the esophagus. In the ventral side, this duct is known as a pneumatic duct. The two sacs sacs are fused into one. At the proximal end, the opening glottis is provided with a muscular sphincter. These two lobes fuse to the proximal parts of the esophagus, and it is provided by muscular sphincter. In the lungfish, Protopterus and Lepidosiren, the condition is similar. The two lobes are equal in size and have thick vascular wall, alveoli and septa. Now we are discussing the Lepidopterus and Protopterus and Lepidosiren fish. In this, to the similar previous fish, they have two equal size of lobes, but the air bladder wall is a thick and vascular, and they will have alveoli and septa. In the Australian lungfish, Neocritidae, air bladder consists of a single lobe laying dorsal to the gut but still connected ventrally to the esophagus by a narrow pneumatic duct passing down along the right side of the gut. The Australian lungfish have only one lobe of air bladder. It is located to the dorsal side, which is open into the esophagus by a pneumatic duct but to ventral sides. In the Holocystine, Emia and Lepidostratus, the air bladder is a single large and highly vascular lobe laying dorsal to esophagus and its pneumatic duct also opening dorsally into the esophagus. Emia also have only single lobes of air bladders. This is open into the esophagus to ventral side, but air bladder is located into the dorsal side. Thus, in Emia and Lepidostratus, the air bladder serves both respiratory organs and a hydrostatic organ. In the Emia fish, air bladders behave respiratory organs and hydrostatic organs. Now we are discussing the condition in teleost fish, means bony fish ની અંદર કેવી condition જોવા મળે તે. The air bladder in higher teleost or bony fishes is the most specialized, playing little or no part in respiration and primitive, serving as a hydrostatic organ. Two types of air bladder are known. In the bony fish, the air bladder is a more specialized organ. It is a play a roles for hydrostatic organ and slightly used for to the respiration. In the more generalization group of teleost like salmon and eel, the air bladders retain connection with the gut versus a pneumatic duct, just as in ganoid and dipnoid. Such an open air bladder is called physostomus. Some teleost fish like salmon and eel have a pneumatic duct, means like to the ganoids and dipnoid fish. The pneumatic duct function they pass out to the air bladder to esophagus. So these types air bladder is called as a physostomus air bladders. In the teleostern Eurythrius, the air bladder has a lateral attachment to gut. In the more specialized teleost, perched and cod, the duct become atrophied or lost. Such a closed or ductless air bladder is called physoclistus air bladder. In Eurythrius fish, air bladders located to the lateral side and pneumatic duct also present to the lateral side. Okay, but more specialized teleost fish not have a duct, means ductless air bladders. So it is called as a physoclistus air bladder. Now we are discussing the basic structure of air bladder. In this figure indicates a structure and blood supply of a ductless teleost fish. This is a postcardial vein. It is a dorsal aorta. These figures is indicate air bladders. The air bladders are divided into two lobes. First lobe is called as anterior chambers and second lobe is called as Posterior chamber. Anterior chambers is large than to the posterior chambers. Now we are discussing the anterior chambers. The anterior chambers made up of two connective tissue layers. Outer side layer is called as a tunica externa and inner side layer is called as a tunica interna. This layer is covered by the many blood capillaries. Now also seen a rounded like structures in the anterior chambers. It is known as a red gas gland because this gland color is red, so it is called as a red gland. They have a rete mirabilis. Rete mirabilis is form of many blood capillaries. They have arteries and vein. The ciliac mesenteric artery open into the red glands by bloods, and this blood is imparted into the hepatic portal vein. Okay. Now we are discussed to the posterior chambers of the air bladders. The posterior chamber also have many arteries and many veins. They reabsorption of the gas. And the anterior chambers and posterior chamber connected to the sphincter. It is used for construction of the air bladders. Now explain basic structure of teleostome air bladders. The air bladders may be composed of one or two or many chambers. In typical teleos, it is a thin-walled gas-filled sac laying dorsal to alimentary canal, extending the entire length of body cavity. In teleos, fish have a one or two chambers like air bladders. The air bladders wall thin and gas-filled pouch-like structure. It is located dorsal to the alimentary canal and extending to the entire length of the fish or the body cavity. Bloat and Murenia have shown that the gas secreted by the air bladder is mostly oxygen, nitrogen, and little quantity of carbon dioxide are also present. These scientists have shown gas secret in the air bladder. So which type gas are secreted? Like oxygen, nitrogen, and little quantity of carbon dioxide. In higher phyloclistous air bladder, the air bladder in fishes varies greatly in structure, shape, and size. It is essentially a tough sac-like structure with an overlaying capillary networks. In the higher phyloclistous, means these type fish have a phyloclistous like air bladder. Phyloclistous air bladder means this type fish not have a duct, means કે pneumatic duct છે તે present ના હોય. The air bladder in fishes varies greatly in structure, shape and size. Okay, it is a tough pouch-like structure. It is covered by the capillaries network. Beneath the capillary system, there is a connective tissue layer called tunica externa. And below these layers, the tunica interna consists of primarily of smooth muscle fibers and epithelial gas gland. Now we have discussed the in figures the anterior chamber made up of two connective layers, tunica externa and tunica interna, and they covered by the capillaries networks. So the capillary systems beneath have a layer, it is called as a tunica externa, and below this layer is called as a tunica interna, and this layer is made up of smooth muscles fibers and epithelial gas glands. The wall of anterior chamber has a red color, so it is called as a red body or red glands. These capillaries made up of pass out to the bloods. Now in the anterior chambers have a bulb-like structure. It is called as a red body because it is color is red. It contains a compact mass of interlocking capillary called rete mirable. These red glands have many interlocking capillaries, so it is called as a rete mirable. The air bladder receives its blood from branches of ciliac mesenteric artery or directly from the posterior branches of dorsal aorta and imparts into the hepatic portal vein. The air bladders receive a blood from to the ciliac mesenteric artery or directly posterior branches of dorsal aorta, and this blood is imparted into the hepatic portal vein. The posterior chamber is thin walled and from the oval gland which permit reabsorption of gases by the blood. Now we are discussing the posterior chambers of the air bladder. So the posterior chambers wall is thin and form oval glands and permit a reabsorption of gases by the blood. Means the anterior chambers secrete a gas in the blood, and then posterior chambers is a reabsorption of gas by the blood. Secretion and reabsorption are control of autonomic neural systems. Secretion and reabsorption process is control to the autonomic neural system. In physostom feces. Now we are discussing the physostom feces air bladders. The air bladder connected by pharynx by a duct. Air can also be bulbed through mouth. The air bladder is connected to the pharynx or esophagus by duct, so it is called as a physostomous feces because they have a duct. And air can also be bulbed through. Now we are discussing the function of air bladders. So the air bladders have many functions. The air bladders or swim bladder in feces perform a numbers of functions, the more important of which are discussed below. First function is hydrostatic organs. The air bladder serves as an important hydrostatic organ in feces and help to keep the weight of the body equal to the volume of the water the feces displaces. Feces migrate to the one place to another place. Now, the fish body weight is equal to the volume of the water. This type function is called as a hydrostatic. It also serves as a equilibrate the body. A secretion of more gases means lower specific gravity so that the fish rises in water. Now we has discussed to the air bladder structures. In the anterior chambers is a secretion of the gas because then secretion of more gases the lower specific gravity of the fish body, so fish is rise in water. Reabsorption of gases means increased specific gravity, the fish sink. Fish reach to the atmosphere, so the reabsorption of gas by posterior chamber of air bladder now increased specific gravity, and the fish is sink in water. Thus, the fish is able to rise or sink and maintain its equilibrium or position in water without any muscular effort. The fish is sink or rise. This process is maintained of the hydrostatic organ is air bladders. This is a equilibrium or the position in water without any muscles efforts. Air bladders through તે ફિશ છે જે સિંક એન્ડ રાઇસિસ કરે છે એમની અંદર કોઈ મસ્ક્યુલર યુઝ થતા નથી. Now we are discussing the second function of the air bladders. It is known as respiration. The original function of the air bladder was probably respiratory. Air bladder function is respiration. A cellular lungs-like air bladder is present into the teleostomes like Polypterus, Emia, Lepidostasis, in which it is a primarily respiratory in function. The air bladder present into the teleostome feces in Polypterus used air bladder for respiration. In Dipnoi, the air bladder resembles closely with the amphibian lungs. These fish come to water surface regularly to gulp air. In lungfish, the air bladder structure slightly similar to the amphibian lungs, and the fish come to the water surface regularly and they gulp to the water air. In Physostomus, means with duct air bladder, this type air bladder occurs to this fish teleost. Now we are discussing the third function of the air bladders. It is also known as a sound production. The air bladders play an important role in sound production. Some fishes are able to produce sound with the gases inside air bladder by the use of special muscle attached to the air bladders. The air bladder play an important role in the sound production. Some fishes produce a sound with the gas entering to the air bladder by the use of special muscle. Means air bladders have some special muscle and this muscle attached to the air and air bladder produce a sound. But the actual mechanism is not understood. Many fishes like Dorus, Plaitostoma, Melapteros, Trigla can produce grunting or hissing or drumming sound. Many fishes can produce a grunting or hissing or drumming like sound. The circulation of air inside the air bladder causes the vibration of the incomplete septa, which in turn produce sound. The air is circulated in the air bladder. These times, the air is pass out to the wall of the air bladder. The wall is vibration and form a sound. The sound may also be produced by compression of extrinsic and intrinsic musculature of air bladders. Air bladder muscles, extrinsic and intrinsic composition produce a sound. Polypterus, Protopterus and Lepidosiren can produce sound by compression and forcefully expulsion of gases in air bladders. Air bladder expulses of gas by forcefully. In cynocean snails, the compression of the air bladder is achieved by contraction of specialized muscles. The air bladders have a specialized muscles and it produces sound. This is known as a muscular sonificus. The sound produced serve to startle the enemies or attract mates. This type of sound production used for the protection to the enemies or attracts to the females format. Now we are discussing the last function of the air bladder, auditory function. In Cypriniformis, a series of small bones, the Weberian ossicles connect the air bladder and perilymphus cavity contains internal ears. Many small bones present into the Weberian ossicles. It is these ossicles connected to the air bladders and perilymph cavity contain a internal ear. Low frequency vibration of the conditioned gas induced by noises in water and transported by the ossicles to the membranous labyrinths, thus these fishes can hear. Air is low frequency vibration induced by the noise in water and they transmitted to the ossicles and to the membranous labyrinths used and these fish can hear. Thank you.